Hello GCC, here we are in chapter 10 again. I promised you I would show you the answer to the hard problem at the beginning of this video, and there it is. We have nickel 3 sulfate. Remember, the 3 in parentheses means that's the charge on the nickel. So nickel has a +3 charge. Not that there are 3 nickels, because if you look, there's only 2 nickels, Ni2SO4 in parentheses 3. And then we add it to lead 2 nitrate, meaning lead has a +2 charge. And we produce nickel 3 nitrate and lead 2 sulfate. And if you balance it, it's 1, 3, 2, 3. So that was a hard one. I hope you did a good job on that one. Let's move on. We are now going to look at 6 types of chemical reactions. So you need to learn these 6 types, and these are generic examples here. So combination is just 2 chemicals combining together into one, represented as an A plus B makes AB. Most of the reactions we've done so far have been combinations, like when we did sodium plus chlorine makes sodium chloride, and aluminum plus bromine makes aluminum bromide. Those were combination reactions. Decomposition is the flip side of combination. It's when you have one big chemical breaking down or decomposing into 2 or 3 little chemicals. And this is represented by the generic ABC makes A plus B plus C. So those are reverses of each other, combination and decomposition. Now the next 4 are more complicated, and you have to learn how to write the products for them on your own. Combustion is always a CH compound. So C2H4, C3H6, C6H6, some sort of CH compound called a hydrocarbon, because it's made of hydrogen and carbon, hydrocarbon. So it's a hydrocarbon plus oxygen gas. Why do we need oxygen gas for combustion? Well, what does combustion mean? It means fire. What do you need to support a flame? Oxygen gas. So we have to add oxygen gas to the hydrocarbon to support the flame for fire. Combustion is fire. So on the reactant side, the left side, we have a hydrocarbon plus oxygen gas. And it's going to make, always, CO2 gas plus H2O gas. It's not water. Whoever had a fire and had water drip out of it? No one ever said, I'm thirsty, start a fire. Okay, so it's H2O, hot gas. The H2O is hot because it's fire, so it's H2O in the gas state. The water has boiled to a gas and it floats away with the CO2 in smoke. Okay, so combustion, hydrocarbon plus oxygen gas makes CO2 gas plus H2O gas. Next is acid-base. We learned about that in chapter 9. An acid has an H in front. A base has an OH in back for the Arrhenius acids and bases. When you have an acid and a base, the H and the OH come together and make HOH. What is HOH? It's water. So we're going to make H2O liquid, and then whatever's left over, M stands for a metal, A is a nonmetal, so we have a metal and a nonmetal coming together. Check your charges. So in the generic example, we have HA, that's your acid, there's an H in front. We have a metal with hydroxide, OH in back, metal OH. The H and the OH make water, and then we have the metal and the nonmetal come together. Check your charges to write the proper formula. That is an acid-base reaction. Single replacement reactions. You have a metal plus a compound. It's an ionic compound or an acid, AX. So you have metal plus AX. The metal's going to take the place of A if it's more active. We'll talk about that later. And you'll make MX, a metal and a nonmetal. Check your charges, plus whatever A is. So metal plus some sort of compound. The metal may be able to replace A and join with X, making MX. Check your charges. It's a metal and a nonmetal. Check your charges. A is left over by itself. So it singly replaced that A. single replacement. We had one replacement. The last one, double replacement. We have metal 1 with nonmetal X. We have metal 2 with nonmetal Y. We're going to have a double switch. M1 and M2 are going to switch and replace each other. So M1 is going to go with Y and M2 is going to go with X. Check your charges for both of them. Metal 1 with Y is a nonmetal, check your charges. Metal 2 with X nonmetal, check your charges. So with double replacement, you have to check your charges twice and make sure you have the proper formulas for those. All right, so you need to learn those 6 types of reactions. Here are 3 reactions. What are they? Combination, decomposition, acid-base, combustion, single or double replacement. You have 6 options. I want you to pause a minute, look at these 3 reactions, and tell me what they are. All right, hopefully you noticed number 1 is decomposition. The P2O5 is a big chemical, but it's breaking down into phosphorus and oxygen gas. It decomposed. Second one, we have a metal with OH in back, and then we have an H in front with F. So that's an acid-base reaction. We don't have to put the acid first. We can put the base first. It's still acid-base. HF is the acid, NaOH is the base. And look at what we made. Water. We always make water with Arrhenius acid-base reactions. There are other acid-base reactions like Bronsted-Lowry, but we're doing Arrhenius acid-base reactions, so we'll make water. The last one, we have zinc plus a compound, an acid. And the zinc joined with the chloride, and then hydrogen was left alone. We had a single replacement going on. Zinc replaced the hydrogen and bonded with chlorine. So, single replacement for that reaction. Good job. Let's talk about these a little more in depth now. Let's start with combination. Combination, P solid plus O2 gas makes P2O4. Again, the P's and the O's join together to make one compound. Pause for a moment and balance this reaction. All right, I hope you were able to balance this reaction. You need 2 P's on the reactant side. So we have 2 phosphorus atoms on both sides. Then because we have 4 O's on the product side, we had to put a 2 in front of O2 to make 4 O's. So we have 2 P's and 4 O's on both sides. That is your combination. Good job. Decomposition. We have Fe2O3 solid, arrow, Fe, and O2. We have a big chemical to start out with, and it's breaking apart into the iron and the oxygen. Again, hit pause and balance this reaction for me. Pause. And hopefully you were able to balance this reaction. We need 2 Fe2O3s on the reactant side, and we're going to make 4 Fe solids on the product side and 3 O2 gases. This way we have 4 irons and 6 oxygens on both sides. Hopefully you're getting better at balancing these reactions. All right, this is where we're going to pause on this video, and we'll start up the next one with some combustion reactions and acid-base reactions. So farewell, GCC. Have a good day.